why I can't do that math.
Yeah.
7 plus 17. Okay, perfect. All right. So we went from grams of lithium hydroxide to moles, and that gives us 1.24 divided by 24, 0.0517 moles. And from there, I can just divide by my liters. And so when I'm dividing by liters, is it 97? It's 0.097, right? We got to move it 3 places. And so we get a molarity equal to 0.533 molar. Okay. So this one didn't ask for any particular ion, so we can stop right there, right? It just asked for the concentration of the solution as a whole. So we're done. Right? We didn't have to do anything with the mole ratios or anything like that because it was just the molarity of the entire solution. Okay? Questions with that one? Okay. All right, so I want to read through this first and let you digest just a second. So it says, a 0.1 gram sample of copper metal is dissolved in 35 milliliters of nitric acid to form copper ions. Right? So it's put into this solution so that it can dissolve and ionize. After that, water is added to make a total volume of 200 milliliters. Calculate the molarity of just the copper ions. Okay, of just copper ions. So in this question, we're not starting with a formula. We're just starting with copper itself, right? It's copper metal, so that means it's just copper. When it's dissolved in nitric acid, it ionizes, which means it really just has to do with transfer of electrons. So there's not a whole lot that has to happen here except for we need to convert our grams. Sorry, I think I clicked on that. I need to convert my grams to moles of just copper. Okay, sorry, my question went away. I'm trying to get it back. Of just copper? Right, it's just copper. So I want to convert grams to moles. .1025 grams of copper. Copper 63.5. Okay, and that means I have 0.00161 moles of copper present. All right, that's how many grams I started with. So this is how many moles I'm putting into that 35 milliliters of nitric acid. Okay? It does not change the number of moles if it's copper or copper 2+. Right? It doesn't make a difference. Okay? Well, it doesn't matter if it's ion or the regular. But that's how many moles is going into this solution, right? So it's originally put in 35 milliliters of nitric acid. But then we add enough water to make it 200 milliliters. So when I'm trying to find the concentration or the molarity, I'm going to take this number divided by the whole 200. Right? The 35 doesn't really affect us here. Right? It just says that we added to make a total volume of 200. It's important here that you're not taking 200 plus 35. All right, we had 35 mils to start. We added enough to make 200. So when I'm calculating that, I'm going to take the moles of moles of copper that I started with, divided by 0.2 liters, and I get 0.0081 molar. Right, we put this copper into the solution. It dissolved, but now it's just copper ions. It's still copper. It's just copper with a +2 charge. And then we added water to that, and that diluted the solution and made it less concentrated, right? So there's our molarity. But the amount of copper didn't change when we added that water. Okay? It's really important that this problem said it added to make a total volume If it would have just said we added 200 milliliters, then our final volume would have been 235. So you just have to pay attention to the way that question is worded. Okay. Now we're going to go into ions. Calculate the concentration of all ions present in this example. Okay, all ions present. So I'm going to give you a minute to get it written down, and then we'll start working through it. So the first thing I want you to think about here is, what ions does this substance break into? What ions would it form? Calcium would be 1, and it would have a charge of +2. And then how many nitrates would it break into? 2 NO3 minus. Okay, I think this might be a good exercise for us to start looking at where do they break into and how many of them would there be if they ionize. Right? I think that might be a good extra step for us to maybe start doing, is when they're going to ionize, what is it making? Okay, so now we can look at, we were given the moles and given the volume. So we're asked to calculate the concentration or the molarity. So I want you to just think about this before we even solve the problem. If I have 0.1 moles of my total formula, how many moles of just calcium do I have? 0.1 moles of Ca plus 2, right? Because for every one calcium nitrate molecule, there is one calcium atom. So that means for every 1 mole of this substance, there's 1 mole of calcium. And so for every 0.1 mole, there's 0.1 moles of calcium. How does that apply now to nitrate? How many moles of nitrate are present? 0.2. NO3 minus 1. Right, we'd have 2 of those. Emily, actually, you can just put it right there on my desk. Thank you so much. Okay, so now I've got the amount of moles of each, and I can just divide by my volumes to get my concentrations. Right, this is a little bit different approach to how I taught it yesterday, but I hope this makes it a little bit clearer, right? This one we started with moles, and we just have to look at, if this is my moles of total, how many moles of each ion do I have, and then I can solve from there. Maybe that makes it a little bit clearer for you. So if I'm going to solve for concentration of calcium, I'll go 0.1 moles divided by 0.1 liters. That gives me 1 molar. Here I would go 0.2 moles of nitrate over 0.1 liters, and I get 2 molar. Okay? So when we're given our mole amount to start with, hopefully it's a little bit simpler for you to look at the relationship first, and then you can solve for molarity. Okay, I'm not sure if I spelled that out as clearly yesterday, so I want you to make sure you can visualize that. Find the concentration of sodium ions only. In the last one, we found the concentration of each ion. This one's sodium only. 2.5 moles of sodium sulfate in 1.25 liters of solution. Okay, I'm going to give you a head start and let you guys try this one on your own. I said if we started with 2.5 moles of the whole thing, based on this 2 right here, that tells me I have twice as many sodium ions as I do total molecules, right? Because for every molecule, there's 2 sodiums, right? So I've got twice as many sodium atoms as I do full molecules. Does that make sense? And then once I found out I had 5 moles total, then I could take that divided by my total volume.
So you don't need to find like a ratio for this one.
Right, so the other way you could do it is I could say, well, I found the ratio when I did this part right here. There's 2 moles of sodium to 1 mole of sulfate, right? This one didn't require you to do like a chart though, like a T-chart, right? Because we started with moles. Ones that might require a T-chart are ones where we usually are starting in molarity, and then you find moles and then look for your ratio from there. We're going to do one like that next.
So is concentration and molarity the
Yeah, those can be used interchangeably, right? Molarity is the unit for concentration, right? So when we say find the concentration, that's going to be molarity. Yeah. Okay, let's try one last one here. What's the mass of NaOH that's contained in 250 milliliters of a 0.4 molar solution? So mass means really we're solving for grams. Right? That's what mass means. So based on my molarity equation, what do I have to solve for first before I can even get to there? Moles. I have to solve moles first, okay? So I'm given my molarity. I'm going to be solving for moles. And I know my volume is 0.250. And so when I found that in moles, that's moles of my total, right? That's moles of my whole compound in this solution. And it asks me for mass of my whole compound in the solution. So I don't have to do any extra mole ratio or anything because I'm looking at big picture, not individual, right? So once I have that, I can just find the mass of sodium hydroxide, which I kind of think is 40 grams to 1 mole. 0.1 divided by 40, and that tells me that I have 0.0025 grams of NaOH. Oh, yep, you're right. Thank you. Sorry. Yes. No, you're right. Just tell me when I do something wrong. There we go. That's better. So now I can go 0.1 times, okay, I even knew that in my head that my answer was going to be 4. Okay, there we go. 4 grams of NaOH.
How do you do it again with the moles on top? Does the 2.5 go on the top or bottom?
They are going to get multiplied together. So I need to get moles by
well, okay, well then
when it's the other way around, like if I have molarity, if I'm solving for this one, I switch these two places. So it'd be moles over molarity if I'm solving for volume.
You just put volume, but we have to switch it into liters.
Yeah. I just did that without saying it out loud.
Okay. I was just making sure.
For volume, that's gonna be what?
Volume needs to be in liters, so I put that right into liters.
I mean, like for Blair's question.
Okay, if I was going to solve for volume, okay, so, yes. So don't pay attention to this question. Let's say that I had a 2 molar solution that contained 1.4 moles. How many liters is in that solution, right? So I would switch these two places, and I would say liters equals 1.4 moles divided by 2 molar. 1.4 divided by 2, that means I would have 0.7 liters. Right? So if your variable's on the bottom, you switch those two places. Yeah, Sophie?
So I'm still confused on like what molar means. Like I know it's concentration, but like,
Right.
what does it mean to have like 0.4 molar?
0.4 molar is the value of the concentration. Molar is just the unit that goes with it. So it'd be like saying we have a distance of 10 meters, right? Meters is just the unit that goes with it. So molar is just the way we say this is how much the concentration is. And when we give the concentration value, that's saying if it's 0.4 molar, that might say that we have 400 grams per, I don't know, 10 milliliters or whatever it happens to be, right? It's telling us how saturated the solution is. So it's telling us how much solid has been dissolved in this liquid, right? And the bigger the molarity, the more concentrated the solution is. So think about it in terms of Kool-Aid, right? If you've got a high concentration, that means it's really dark, thick, syrupy. And if you've got a low concentration, it's really watered down. Does that help?
Yeah.
Okay. Any other questions? I have some more types of examples like the homework in the practice problems we're going to do as a class, and I'll be around to help if you need help with that. Okay?